Yeah, so hi everybody. So my name is Henri and I am the co-founder of OK Contract. And today we're going to talk about why smart contracts need more front ends. So right now, when you want to use smart contracts, most often you'll go to the dapp, which is built by the same team that has built the contract. So for instance, if you want to play a game in the sandbox, you go to the sandbox page, and then you will find the game event that you want to participate with. You're gonna find, follow, click to the link to mint the NFT, the avatar, which is required, and you'll follow maybe a few other links and you'll mint it, but you started from the dapp. If you want to borrow or lend assets, maybe you'll go to Compound Finance and you'll go to their own dapp and lend and borrow there, etc., etc. Same if you want to trade perps on GMX, or if you want to provide liquidity, for instance, on Uniswap, you go to the same dapp, which is built by the team who wrote the contracts. There's an exception to that, and that's quite interesting. For instance, Uniswap is building widgets as an SDK. So you can use the Uniswap widgets and embed them in another site. But this is just for Uniswap, and they built this SDK manually. And the question is, can we do the same for every contract? That would be cool, no? And so here is something very interesting, of course, with smart contracts, is that they're permissionless. So you don't need, in Web 2, you would need to, let's say if you want to integrate with a given startup, you need to call them, maybe call the sales team, get an API key so you can build your own front end, your own interaction. But smart contracts permissionless. No call us for the API key. So you can just directly build a front end. What do you need to do that? Obviously, you need the deployed contract address, you need the method, you need the ABI, and if you want to program it yourself and not just go to Etherscan and use the simple bare bones generated interface, then you'll need maybe a SDK. And this is how, for instance, if you remember Loot, you've been minting a very cool list of items, and there was no front end at all provided by the project itself. You'd go, so again, maybe to Etherscan and call mint. But that's a very easy case, because mint has no parameters, and also the mint was free, so there was no value. Because otherwise, you would need to convert and format the right amount and take 18 decimals, etc., to put the price. So free mint, just no parameters, that were easy. But maybe if you want to deal with more complex and real stuff, you need more than a few SDK. So let's look at a real example, and let's look at the implementation of Uniswap v2 for one contract, the router, one method, add liquidity, and their React.js implementation. So we see here exactly what we said. There's a few SDKs. So we find there's Ethers.js, there's Uniswap own SDK core, there's Web3 React, there's React, of course, and a few frameworks. But we're just getting started here, because the actual implementation is more than 500 lines of code. And again, 500 lines for just one method of one contract, but done extremely well. So this is the, let's say, the quality that we want to reach. Uniswap provides a very good experience, and this is what we expect. So going a bit more into the other imports, we see there's a lot of React hooks, so which are not counted in these 500 lines. So there's hooks to compute the currencies, there's hooks to get the balances, there's types important for transaction, etc., lots of utilities function. So it's quite complex, and again, it's repeated for every page that is built. If you scroll down a bit, you'll go to add liquidity, and then maybe we'll start finding what interests us is the semantics, in fact, of that particular transaction. And then you see here we start assembling together the parameters, but mostly it's about getting the right inputs in that application. And there's also some theming coming in. You see const theme equals used theme. So we still have to scroll down a bit more to find what we want is the semantics again. So here we see, there's transaction values. So here we see we are computing the deadline, for instance. We're computing the slippage of that transaction. We have some formatting for the amount, but we still have to scroll down, where we finally instantiate the contract, the router contract, and we go down, and then, we add our transaction parameters. There's the on-add callback. Here we compute the amounts, and it goes and goes and goes on over 500 lines, because here we didn't even start the GS6 components. So again, on add, here we call the gas estimation, we manage the event, we put together the values. So, and here it's more than 200 and still not the GS6. Why that? Because unlike the very easy loot mint, here on DeFi, when you want to do something, you have to do client-side computations. And these client-side computations may require calling other contracts to get some data, some inputs. Then you need to manage wallet changes, chain changes, customize the interaction with balances, manage approvals. So there's a ton of stuff to do. And often it's more than one transaction. You have the approval, you have maybe you are staking something after you swap a pool. So maybe that's 1, 2, 3, 4, several transactions. And we didn't touch NFTs, which will be left for maybe another talk, where you have also to manage off-chain data. So can we stop here and say, can we do this simpler? And at OK Contract, we spent a lot of time figuring out what is exactly the problem that we're trying to solve, and how can we find a proper, let's say, computer science way to solve it. And this is where we thought, okay, the start of it is the intent of the transaction. We want to swap X A tokens for YB tokens. We want to buy the floor of an NFT collection. We want to mint an NFT with some attached metadata, maybe. And okay, we start with the intent, and now how do we automate it? And we found out that the approach to solve this resolves around 3 things. First, it's a standard way to specify the smart contract interaction. Then, we want to automatically create a transactional interface from that specification. And it has to be a generic approach, not something that you do manually for every contract and for every method. And then third, an easy way to embed, in fact, that automated interface into any web page and a web app. And this is the famed, I would say, Web 2 to Web 3 that we speak a lot about in the community, because this is how we'll bring much more users, in fact, to everything we build. So let's start digging in with how we specify the smart contract interaction. For this, we have introduced a new language, which we call Lambda script. Lambda script is a purely functional programming language. And so it has no side effects at all. And this enables automated reasoning and enables static analysis to do very interesting things. And we specify what we call a low-level intent or a high-level transaction. It depends when you put the cursor. But basically, if the intent swap X A tokens to YB token is very, very high level, what we want to specify is an intent. It's not 500 lines of JavaScript code. It's just an intent of the semantics of interacting with a given contract on a given method. So just to give you an example, this is the complete implementation in Lambda script for another method of the same Uniswap router, which is swap exact ETH for tokens, because this is a method that many of us know quite well. So here we say, okay, we're minting $2 which is a special value in the environment. And for token A and B, we see that we integrate knowledge base, a type knowledge environment about tokens, where we can retrieve the precise address for each of the tokens using a unique ID. And then we construct values like a path, which is an array made of token A and B, deadline, a standard library function, and very important amount at min, which computes basically the slippage value. And all this, if you think about it, this is our low-level intent or high-level transaction. We specify exactly what we want to do. And from that definition, which we call the Lambda script program, then we compile it to bytecode, or gives an error if there's something wrong with the specification of that program. And then when we'll have user inputs, basically, we'll merge together the bytecode and the user inputs in a VM, which runs basically the transaction and outputs the transaction to the wallet, or gives an error if there's something wrong with the parameters or with the contract, that maybe the contract has changed or the contract is fully minted or anything. Second step, when we have this specification, then we can automatically generate the interface for that transaction. So basically, we go from bytecode to something highly visual and which is fully automated from that specification, not something that we need to toggle and that we need to re-implement for every contract or every method. And here, it's just a cartoon, but we have actually built it, and all these are screenshots. Those are real example of transactional interface which we have auto-generated with OK Contract. And you can see there's NFTs, there's DeFi, it could be multi-step transaction as well, where we can do swap and stake and many other things. We support themes, as you could see, with gradients and everything, input detection, error management, gas estimation, and all this is done, I would say, once and for all. And finally, when we have this, we can easily embed that interface into any web page or web app. All this widget interaction that we have, we can put it into any web page, which was the goal. Something like Uniswap did manually for one method or two methods from their contracts. We can extend and generalize to any contract and any method. And the runtime architecture for it is basically that we have this widget which interact directly with the wallet, including pretty soon with account abstraction wallets, of course, which will change overall the whole UX. And then the component can interact directly with the RPC, can also support IPFS, including upload via pinning to IPFS via other decentralized services. And we can as well provide data, which you have seen, like the list of tokens and several APIs, in fact, that power the web services, which directly connect to the widget and itself. And this is how, in fact, we have built a graphical editor where you can just choose a contract, select a method, define your Lambda script program, which is, again, the low-level intent or the high-level specification of that transaction, and then it generates the program which will be compiled, in fact, to the bytecode and run inside the VM so that we can put this and run this transaction into any web page. So if you get back to the title originally, how we will have more front-end, we'll have more front-ends very soon because we are almost ready to release it publicly. Right now, we started in private beta, so we've been working with projects like Compound and Alchemix, for instance, in DeFi, where we do multi-step transaction to migrate liquidity between several pools, collect rewards, and restake them in Aura. And we're working with the Sandbox as well, where we're going to onboard many partners and agencies doing transactions for all the brands that use the Sandbox. And all this will be available really, really soon. We just wanted to make sure that we iterate a lot on the specification before we release it publicly, so we can publish it as a standard and release the open source components, and so that basically it's something that will be stable and that you will all be able to build upon, and not something that will be shaky and that will iterate quickly upon release. And this is why it's not publicly released yet, but it's coming very soon. So if you want to support us, please tweet about it and follow us on Twitter, and I'll tell you why. is just because that we're gonna release batches of invites to the platform before the public release. And if you follow us on Twitter, you'll know exactly how to use some OK contract widgets to mint the NFTs that will open the gates to the platform and which enable to test with your contracts. So thanks again to all of you. And if you have any question, feel free to catch afterwards. Thank you.